Nearly 1 million miles from Earth, beyond the reach of our atmosphere and far from the interference of city lights, radio signals, and planetary heat, a remarkable observatory drifts through space in near silence. Its mission is unlike any telescope that came before it. Rather than focusing on the universe as it exists today, it is designed to look deep into the past, capturing ancient light that began its journey billions of years ago. Every observation offers a glimpse into an era long before Earth formed, before the Sun existed, and before the Milky Way reached its current shape. In many ways, this telescope functions as a time machine. Light travels at a finite speed. When we look at the Moon, we see it as it appeared just over a second ago. When we observe the Sun, we see it as it was roughly 8 minutes in the past. But when astronomers study distant galaxies, they are looking millions or even billions of years backward through cosmic history. The farther away an object is, the older the story its light carries. Some of the faint signals reaching the telescope today began traveling across space when the universe was only a tiny fraction of its current age. Those photons have crossed unimaginable distances, surviving encounters with gas clouds, galaxies, and cosmic expansion before finally arriving at the telescope's sensitive instruments. Each photon is a messenger from another era. Together, they help scientists reconstruct the history of the cosmos. One of the telescope's most fascinating discoveries involves galaxies that formed surprisingly early in the universe's history. For decades, astronomers believed that the first galaxies would be relatively small and simple. According to many models, it should have taken considerable time for matter to gather, stars to form, and complex structures to emerge. Yet observations have revealed something unexpected. Some of these ancient galaxies appear far more developed than anticipated. Despite existing only a few 100 million years after the Big Bang, they already contain enormous populations of stars. Their structures appear organized, their stellar activity is intense, and their growth seems to have occurred at a remarkable pace. This raises important questions. How did such massive systems form so quickly? Did the early universe evolve faster than scientists once thought? Or are there physical processes at work that we do not yet fully understand? The answers remain uncertain, but the discoveries suggest that cosmic history may have been more dynamic than previously imagined. Even more revealing are the chemical fingerprints hidden within the light of these distant galaxies. When astronomers separate starlight into its component colors, they create what is known as a spectrum. Embedded within that spectrum are clues about the elements present inside stars and gas clouds. These patterns function almost like cosmic barcodes. By reading them, scientists can determine the composition of objects located billions of light-years away. In several early galaxies, researchers detected evidence of elements heavier than hydrogen and helium. This finding carries enormous significance. The earliest universe contained very few heavy elements. Most were forged later inside stars through nuclear fusion. When massive stars reached the ends of their lives, they exploded and scattered those newly created elements into surrounding space. Finding oxygen, carbon, and other heavy elements in very young galaxies suggests that stars were already being born, evolving, and dying at extraordinary rates. In other words, the universe may have begun building complexity much earlier than expected. The atoms necessary for planets, oceans, and eventually living organisms were already being manufactured while the cosmos was still in its infancy. While some observations focus on distant galaxies, others examine far stranger objects much closer to home. Among these are brown dwarfs. Brown dwarfs occupy a unique position in the cosmic family. They are larger than planets but not massive enough to become true stars. Without sufficient mass, they cannot sustain the long-term nuclear fusion that powers stars like our Sun. For many years, astronomers viewed them as relatively simple objects. Recent observations tell a different story. Their atmospheres are surprisingly complex, containing layers of gas, clouds, and chemical compounds that interact in ways researchers are still trying to understand. Some appear to experience powerful storms capable of reshaping atmospheric patterns over time. Others display mysterious variations in brightness, suggesting dynamic weather systems operating beneath thick cloud layers. Scientists have also observed evidence of intense magnetic activity. In certain cases, glowing emissions resemble auroras similar to those seen near Earth's polar regions. These displays indicate that brown dwarfs may possess magnetic environments far more active than expected. Some researchers even suspect that unseen companions could be influencing these phenomena. A hidden moon or nearby object might leave subtle traces through gravitational interactions, revealing its existence indirectly rather than through direct observation. These discoveries demonstrate that even seemingly ordinary objects can possess extraordinary complexity. The telescope has also transformed our understanding of planets beyond our solar system. Thousands of exoplanets have already been discovered, but detailed observations continue to reveal systems unlike anything astronomers expected. Many planetary systems appear chaotic compared to our own. Some giant planets travel along highly elongated orbits, swinging dramatically closer to and farther from their stars during each revolution. Others orbit at extreme angles, suggesting turbulent histories shaped by collisions, migrations, or gravitational encounters. These systems remind us that our solar system may not represent the universal standard we once assumed. Nature appears capable of producing planetary arrangements far stranger than the orderly configuration familiar to us. Among the most dramatic observations are worlds experiencing slow destruction. Certain giant planets orbit extraordinarily close to their parent stars. The gravitational forces involved are immense. Over time, these forces stretch and heat planetary atmospheres, causing material to escape into space. As the process continues, the planet gradually loses mass. Gas streams away from the world and spirals toward the nearby star, creating a spectacular but temporary phenomenon. Eventually, the planet may disappear entirely. Its material will become part of the very star it once orbited. Such events illustrate an important truth. Planets are not permanent fixtures of the universe. Some collide with neighboring worlds. Some are ejected into deep space. Others are consumed by their stars. Cosmic evolution is an ongoing process, and stability is often temporary. Beyond planets and stars, the telescope has also observed enormous disks of dust, rock, and ice surrounding young stellar systems. These swirling regions are the construction sites of future worlds. Within them, countless particles collide and merge under the influence of gravity. Over millions of years, small grains become larger fragments. Those fragments grow into planetesimals. Some eventually become full-sized planets. Others shatter during violent impacts, creating new generations of debris. The process is messy, unpredictable, and extraordinarily complex. Yet it is responsible for producing entire planetary systems, including our own. Every observation collected by the telescope contributes to a larger story. A story spanning nearly 14 billion years. A story of matter gathering into stars, stars creating elements, and those elements becoming planets. A story of destruction giving rise to creation. The calcium in our bones, the oxygen we breathe, the carbon that forms the foundation of life, all were forged inside ancient stars that lived and died long before Earth existed. In a very real sense, humanity is connected to the cosmos at the deepest level. We are products of the same processes unfolding across distant galaxies today. As the telescope continues its mission, it sends back more than images. It sends clues. Clues about where we came from. Clues about how galaxies evolve. Clues about how planets form and whether life might exist elsewhere in the universe. Some discoveries confirm existing theories. Others challenge assumptions that scientists have held for decades. That is the nature of exploration. Every answer opens the door to new questions. And every observation reveals that the universe is more intricate, more dynamic, and more surprising than we once imagined. The story of the cosmos is still being written. With every ancient photon captured from the darkness of space, another page is added to that story, bringing humanity one step closer to understanding its place within a universe that continues to evolve, expand, and astonish.